Yes. Is it so? Any questions from electrostatics part? Hmm? So can you just go through for some time electrostatics part? Can see this afterwards. Question number 8, page number 38. The question is two electric charges of plus 10 power minus 9 coulomb and minus 10 power minus 9 coulomb are placed at corners A and B of an equilateral triangle ABC of side 5 centimeters. The electric intensity at C is. Let us consider the triangle. This is a triangle. Right. So two charges are placed at two corners A and B. Let's say this is the corner A, this is corner B, this is C. Here we have kept a charge Q1 whose magnitude, whose value is 10 to the power minus 9 coulomb is 1 nanocoulomb. Here we get charge Q2, which is equal to minus 10 power minus 9 coulomb is minus 1 nanocoulomb. Then the question, and each is having a side length is equal to a triangle of same side length, whose A is equal to 5 centimeters. So the question is the electric intensity at C. What is the electric field intensity here? Whenever you are asked to define electric field at any point, you have to keep a test charge, positive test charge at that point, right? Positive test charge. So, hmm, what happened? So you have to keep, whenever you are asked to find field at any point, you have to keep a unit positive test charge at that point. So if you keep a positive test charge here, this is a positive charge, so it will repel, and the field, force and hence field will be along this line. Let's say this field due to the first charge, and this is the second one, the negative charge. So force and hence field due to this will be along this line joining this. Okay, so let us say this is E2. This is E2. So what resultant of this two? What is the resultant of this two? Oh, you are asking to find only the magnitude part, right? So direction is somewhere here in between these two. So if you want to know what is the magnitude of this, you have to use what you call equilateral. I mean parallelogram law. According to parallelogram law, the resultant field is equal to square root of E1 square plus E2 square plus 2 E1 E2 cos theta. Right? Here, if you observe here, E1 is usually electric field due to a single charge should be E is equal to KQ by R square, right? KQ by R square. Here, Q is this magnitude is 10 power minus 9 coulomb, means 1 nanocoulomb, right? So you can take this as this is Q, and R is this A. Whereas E2 is also, it is E1, E2 is also equal to KQ by R. Here R is here, A, you can take it as A square, KQ by A square. Here also it is KQ by R square is KQ by A square only, magnitude wise. So, but sign, direction will be in this direction, okay? But magnitude of these are equal. So, you can say E1 is equal to E2 is equal to E. Can we say? Now, what about theta? Theta is angle between this. By symmetry, if you can say that yeah, you say what will be this angle? You draw a vertical here. Hmm? So angle between vertical this and this will be 90, right? And the and this actually this is 60, right? This is 60 equilateral triangle. The other way you can say that the angle between this point in horizontal and this will be 180. 180 minus 60 will be 120. So this angle you can say it is equal to 120. Theta is equal to 120. Is it clear? So as theta is 120, okay, 120, we can find the resultant electric field as E is equal to square root of E1 square, E1 equal to E, E2 equal to E, so you can say E square plus U square plus 2, E square plus E square plus 2, E1 into E2 is E square into cos 120 is 90 plus 30 you can write. 90 plus 30 is minus sin 30. So it is minus 1 by 2. Minus 1 by 2. 2 to cancel. It will be E square minus C square. You cancel out and 1 E square will be there. So you can say it is equal to E. Is it clear? E resultant is equal to E only. So therefore, E is equal to, what is that? E K Q by A square. Where K is 9 into 10 to the power 9. Q is 1 nanocoulomb. 10 power minus 9. A is 5 centimeters. So it is equal to, and here A is equal to 5 centimeters. So it is equal to 5 into 10 to the power minus 2 meters. Whole square means 25 into 10 to the power minus 4. Got it? So 10 power minus 1 plus 1 cancel out. You get 9 by 25 into 10 power minus 4. So the other way, you can also write this as, if you remember some simplification techniques, you can write it as 9 by 10 power minus 4, you can write it as a 0.25. into 10 to the power minus 2. Actually, 0.25 is 1 by 4. So that 4 you can take to numerator and you can write it as 9 into 4. 10 to the power minus 2 comes to numerator, it becomes 10 to the power plus 2. 9 4 36. So it will be 3600. E. Newton per coulomb or volt per meter. 3600. Okay. Then, so work done equal to, you can say, potential difference into Q. Hmm? Here, next question number 9. It is given that the question is, if if 4 into 10 power 20 electron volt is required to move a charge of 0.25 coulomb between 2 points. The potential difference between these 2 points is. So here it is mentioned that if 4 into 10 power 4 into 10 power 20 electron volt is required, means what is this? 4 into 10 power 20 electron volt is rate of energy. Okay, so you have to remember it is energy, so we can say that this energy of 4 into 10 to the power 20 electron volt is required. But electron volt is not a unit of energy, so if you want to convert this into electron volts, you have to remember that 1 electron volt equal to 1.6 into 10 power minus 19 joule. Okay, it is equal to 4 into 1.6 into 10 to the power minus 19 into 10 to the power 20 joule. Further convert it as 4 into 1.6 into 10 to the power uh, minus 20 plus 20 minus 19 plus 20 is 1, so it is equal to 4 into 16. 4 into 16, how much? 64. Yes, 64. 64, so joule. So you can say the energy of 64 joule is required to move a charge, to move a charge q is equal to how much? 0.25 coulomb. SI unit is, it is given in SI units coulomb between 2 points. Between 2 points. So between those 2 points, the potential difference between those 2 points is delta V. Between those points is what is the question. So directly you have to just say that energy required to move, if there is a point this is B, this is A. From, if you want to move a charge Q from here to here, which are having potentials is V1 and V2 or VAVB, you just need to apply, you need to do a work. That work done is equal to potential difference into the charge. And work done is nothing much energy. So, okay, you can also say it is equal to energy, or energy is equal to work done equal to this. From this you can say potential difference delta V is equal to energy by Q. Energy is how much? 64 joule, and the charge is 0.25 25 coulomb, both are SI units. But 1 by 0.25 can be written as 1 by 4. 4 goes to numerator. So 64 into 4 is equal to how much? 4 4s 16. 4 2 6s 24. 256. 256. What is the unit of potential difference or potential volts? So therefore you can say potential difference of delta V is equal to 256 volts. There is no other 10 powers, right? Because the chart is given in coulombs only, not if it is given microcoulombs something like, you have to be aware of this. So it will be 256 volts. That's it. Okay. Anything else? So go to this please. Is this clear? I think we are discussing this right. Nothing else. This one. Wait, wait, wait. Hmm? Translations. Actually, now I have to schedule another study hour for that. And, yes, it is audible. Yeah. Hmm? So first, only displacement, velocity, and acceleration only, right? Only level 1 have you guys completed? Okay. Yes. Level 1, right? Let's see. Hmm. First, how many are there here? 21. Is this 21 finished? Is 21 finished? Hmm. Is it? Really, every question I asked, every question I discussed about. That's right. I was, you will understand it completely confidently once you have again so repeatedly not reverse number of times. Then the confusion will once if you do if you like understand but again you'll forget. You'll confuse. But if you practice once again something like that some two or three times, then at least a part of the process you'll do. Then you should be able to do without just close it and try. Close it and try. Then if you try at least like that some two or three times, then the process will register some points you have to remember. Kind of I can use the words we call it by heart some method also. If you just remember the step by step procedure, then you can feel easy to do the similar kind of questions. Automatically the concept also can be clear once you even after by hearting the concept can be understood clear. The few things you have to remember. So you have to remember how to remember. Okay? Hmm. 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 If equation is same only, almost same, this kind of equations only. So the different ways you have to calculate. Say for example, you see here, just something like that. You have two waves. We are asked different amplitude of the resultant oscillation. These amplitudes and phase difference you have to consider, right? That if you see here, distance covered by this time interval means from 0 to 3 seconds. Distance covered. This is nothing but what we consider that first you have to know what is time period. That in this time, how many oscillations it has done. Based on it, you have to calculate distance, not displacement, distance. So similar to that, here frequency is given, amplitude is given, initial displacement, initial displacement is towards the positive extreme. Initial displacement means the time t equal to 0 for position. Let's see equation of the right. So time t equal to 0, position is given, it is having some phase difference. The initial phase you have to find out accordingly. So that means every question is giving you some kind of few points about the concept. I would say oscillator motion. So we are understanding about the same oscillator motion in different ways. Simply understanding that this is a particle is oscillating about one position. Okay, amplitude is extreme distance of extreme position, so and so. And equation is this. There, this amplitude, this is frequency. Knowing that is different, but knowing the concept way is different. You have to do it again and again. Then some confusion points will be clarified more clear. Then you will not the revise all same once again the same numerical functions. Into positions so last is one with respect to one thing. This coming just 10 minutes I will change this by that time. Okay. Exactly. 9:10. So actually when I doing all these things
Yes, sir. Just seek total energy in initial part.
by using law of conservation of energy.
Yes, sir.
I have to say by using law of conservation of energy from
Law of conservation of energy. Total energy in initial part.
conservation of energy for question number 17, right? Page number 41. So, you're asked to find what is the velocity of the separation is to do. So, by initially to having one the potential energy as the released from rest, kinetic energy is zero. At two days separation, it will have potential energy plus kinetic energy. By equating them and simplifying this, we get velocity as this. Okay?
Yes, sir. Thank you, sir.
Yes, ma'am.
So, keys are.
Hmm?
You can follow this one.
So,
But in key, do heat page.
will we miss any do something like that? See?
20 minutes.
Mentioning here. Hmm.
But also this is have seen.
Loss of potential energy. Okay, loss of potential energy. Okay. Small mistake we did here. Small mistake we did here. This, this part. Actually, initial potential energy is kq square by d. The final potential energy is okay. Correctly, k q1 q2 by d is 2d. 2d only, right? 2d only. 2d only. Right, is equal to plus half m square. So half m square is equal to k q square by d into 1 minus half. So it is equal to half k q square by 2d only. Right? 2d only. This 2 gets cancelled. Because half m square equal to hmm? half m square is equal to this. You're not asked to find kinetic energy, right? You're asked to find velocity. Velocity, one more thing. What happens to the velocity? Velocity. Everything else is same according to the given conditions. And then the separation between them. Then the velocity of each charge of mass m, each then the distance between them is 2d. That's it. Nothing else is changing. So I have to cancel this off 2. Then you get this one correct only. So if it is anything other parameters are changing, otherwise The separation, it is becoming twice. Instead of this, if it becomes 4 times, then it will be 8. It's correct one. Key attitude. Quickly. Where you get this? Which one? Which one? Page number? You don't have? Hmm? Question number? Okay. A particle of mass m carrying a charge q1 minus q1 is moving around a fixed charge plus q2 along a circular path of radius r. Then find time period of revolution of q1. So what did you understand from this? It is understood. It is given that it is having a particle of mass m is carrying a charge minus q is moving around a charge fixed charge of charge plus q along a circular path of radius r small r. Find the time period of revolution of charge q1. How much charge? This is one. First one, minus q1. This is minus q. Yes, time period. So if you want to know the time period, if you can find what is that angular velocity, you can find it. Otherwise, you can say a time period is nothing but time taken to complete one revolution around the circumference. So you can say time period is equal to the time taken to complete one revolution means you can say that's t is equal to distance traveled by velocity. Total distance traveled for one revolution is circumference circumference of a circle by with what velocity it is moving. Let us say if it is moving with some velocity v. Okay, you can say take it as velocity. So circumference will be equal to pi r is given here. Anything else is given v. We're asking to find what is the velocity with which it is moving. But velocity is not given, but it is mentioned that they're having charges. So here you can say this is a center we are having one charge plus q2 around this minus q1 is moving. So what you can say when it is moving here, it is said to be uh, whatever the energy it is having. Exactly, it will be holding. So we can say that the energy it is possessing will be potential energy if it is fixed at a point at a distance. And when it is moving with some kinetic energy means we can say that the kinetic energy will be equal to the potential energy. The other way you can also say that when it is moving in a circular path, it will not be converted into the force which is acting on this is centripetal force. Centripetal force. So here the centripetal force is said to be provided by centripetal force is provided by what force? Electrostatic force. Electrostatic force. Hey guys, hit up. Electrostatic force is K Q1 Q2 by R square. Here and centripetal force is mu square by r. Electrostatic force is k q1 q2 by r square. And simplifying this, you will get this velocity. So here from this, you can say velocity is equal to k q1 q2 by m. Right? To substitute this here, we will get 2 pi into or if depending on the given options based on this if you are also you can replace otherwise. So r by v will be k q1 q2 by m. So m goes to numerator. So depending on that you can if in terms of mass they are given, you have to take this mass and radius. If they are given in terms of velocity, r you have to replace with m and v. So accordingly I have to take this. Okay, as centripetal forces providing But, what is that? Electrostatic force provides centripetal force required. It's providing by electrostatic force. So by you have to equate them and you have to calculate this V, or if it is required, V is equal to, oh, R is also there, right? MR, it is MR. K Q1 Q2 by MR. So one more R, so it will become R square. It will get R square. Okay, so that you have to be understand carefully. One second, no? We are waiting.